Good evening, Nanika.
Good evening, sir. How are you?
Okay, I'm fine.
Good
Welcome all.
evening, sir.
Yeah, good evening. See, sometimes what happens when we just when we click on the start, it takes sometimes it takes a minute, sometimes it takes 2 minutes.
Sir,
So
isn't
that's
class
why,
supposed to start at 5:20, sir?
no, class is at 5:30, I think. The
No,
message,
sir.
you can see the message in the group, it's 5:30.
Yeah, sir, you kept the message. I thought it was typo or something. Because usually the daily classes are at 5:20, sir.
Okay, I'll check it out with ma'am also. It's 5:30. Got it? Okay, so that's why I gave it 5:30 only. Okay, we can continue now.
Yes, sir. Sir, actually in the group also it is written as 5:20 only. That's why I was confused.
Yeah.
Good
So in the
evening,
group,
sir.
yeah, good evening. Good evening. Just we are starting again, and today we'll be doing with some other resources. Like in the last class, we just started with combustion and flame. So we did what are fuels. We did the different conditions that are necessary for the fuels. Like yes, just wait. So you have combustion and flame.
Sir, your video is not, your presentation is not there.
Okay, just 1 minute. So one thing I want from all of you, if if during the class somewhere you are stuck, okay, you or maybe you sometimes you may need to leave the class in between, do inform and then leave. Don't just leave like that. Okay, don't just click on the button leave and leave the class. So my video and screen is visible to you all.
Yes, sir.
Okay. So we'll just revise it quickly and then we can move ahead. Since you have your exams, someone is having exams, so we'll do it quickly with a quick revision. So it will be helpful for you all. Then once more we'll do it. Okay.
Sir, I have a doubt, sir. Um,
Yes.
like you can explain in the ending of the class, sir. I didn't understood about the numericals, sir. Numericals.
Which numerical?
About the pressure and force numericals.
President first?
No, sir. From the chapter pressure and force, the numericals are there, right, sir? Those numericals, I'm not getting, sir. Like, I'm not able to do it. I didn't
Okay.
understood.
Okay, see. In those questions on pressure, right? So on the questions on pressure, I think you are feeling problem with
Good evening, sir.
yeah,
Numerical.
good evening. You are feeling problem with just conversion of units. That's the thing that you are facing problem with. Okay. So see, when you are using the formula, pressure is equal to force over area. That can be used everywhere. Whenever you want to find out pressure, so pressure has to be equal to force by area. So now two things that you need to keep in mind, that gravitational force. Whenever you have to find out the gravitational force, so gravitational force would be given by mass multiply 10. You have to multiply that by 10. We write this 10 as g, which we also call as acceleration due to gravity. We can denote it by the symbol g. Okay. So whatever mass is given to you, you multiply that mass by 10. If you have to find the gravitational force acting on an object, so the gravitational force acting on an object will be given by mass multiplied by 10. In reality, the actual value is not 10. In reality, actual value is 9.8. So we have rounded off this value 9.8 to 10 so that your calculations become easier. Got it?
Yes, sir.
Sir, can
So
you
your,
explain once again?
yeah, see, whenever you need to find out the gravitational force will be given by mass multiplied 10. Whatever mass is given, that mass multiplied by 10 will give you the gravitational force in Newton. We
Sir, why
always
10?
why 10? This 10 is the acceleration due to gravity. It is the acceleration with which the gravity pulls any object. So gravity pulls any object with 10 meter per second square. So that is why the gravitational force acting on any object is given by mass multiplied 10. Okay. It is always your mass also has to be in kilogram. This is also a point. Your mass has to be measured in kilogram and not in gram. If it's given in gram, convert it to kilogram. Yeah, Pranav, this is not NCRT revision. Okay. In NCRT, you don't have anywhere like the gravitational forces.
You started Pearson, sir?
Yeah, Pranav?
You started Pearson today, sir?
Yeah, just with after this doubt, I'll be starting with Pearson only. Okay. Just she had a doubt and she has her exam, so I just need to clear it away.
We have on 20th, sir, the exams.
Yeah.
The science exam is on 20th of this month.
Okay, see. So the gravitational force, if you are finding, it will be given by mass multiplied 10. This is beneficial for everywhere. So suppose always here the mass will be taken in kilogram. Remember the mass to be taken in kilogram, and this multiplied by 10 will be the gravitational force. For example, if let's say my weight is 60 kilogram. Okay. So if my weight is 60 kilogram, so the gravitational force acting on me will be equal to my mass, that is 60 multiplied 10. That is, the force will be equal to 600 Newton. Got it? So if your
Yes,
mass,
sir.
okay, let's say, so suppose your mass is 34 kilogram. So what will be the weight gravitational force?
340.
340.
Yeah, suppose your mass is just 34 kilogram. So gravitational force or the force with gravity
340
pulls you
kilogram.
will be 30. Yeah, that's 340 Newton. Not
Newtons.
kilogram, Newtons. Yeah,
Newton,
force is
Newton.
measured in Newton. Okay. Got it, everyone?
Yes, sir.
Then the second thing we need to find out here is area. Okay. Always your area has to be in meter square. This is also a conversion. So all your area has to be in meter square. So how do we measure out area now? Let's say we are given area and area has to be in meter square. Okay, now I think almost everyone has joined. So with all of you, I would just like to say one word, just a 1 minute break. See, first of all your cameras should be on. Okay.
So
So if
power
you are
cut, sir, so I can't on my camera.
okay, so if there is any issue, inform in the help and support. Okay, just inform in the help and support group. So if there is any issue like that. And the second thing is that while in the class, if you suppose want to leave the class for some reason, your mom is calling you or someone else, so half the conversation you can complete from there. But still, if it's urgent to leave, so inform and then leave. This is general guideline for everyone. First inform that sir, I have some urgent work, I need to leave, then you can leave. Okay. Don't just click away and go. So I keep on searching where has he gone. So from next time, if you do like that, I will just call your parents. Okay, don't do those things. All right. Be there. If you have some work, inform and leave. Got it? And whenever your name is called, try to respond as soon as. Gagana,
Yes, sir.
everyone understood?
Yes, sir.
Okay.
Yes, sir. Yes,
So
sir.
see, okay, I'll give you one question regarding this. So everyone has understood this also that the force will be given by mass multiplied gravitational force will be given by mass multiplied 10. Now we need to convert the area. The area will be converted to meter square. The SI system of units, we measure area in meter square. There are other units of area also, but in SI system, area will be measured in meter square or square meter. Got it? So your area will be measured in meter square. Now, how do we measure it in meter square? Suppose the Nyanika, don't turn off. Okay.
Yes, sir. I didn't turn off, sir. It might have switched off due to some glitch.
Okay. So no. Be ready with your pen, pencil, and everything. So area, when it's given in centimeter square, you need to convert it to meter square and see how it conversion takes place. So 1 centimeter square is equal to 1 over 10,000 meter square. It's not 1 over 100. It's 1 over 10,000 meter square. So be careful while converting from centimeter square to meter square.
So, sir, actually 1 centimeter we mostly write is 1 meter is equal to 100 centimeters we write, right?
Yeah,
But we are in squares, so we are writing 1 centimeter is equal to 1 by 10,000.
10,000. Yes. So
Sir,
that's
Then
the
we need to
reason.
remove the squares, right, sir?
Sir, I know the reason because 100 square is 10,000 no, sir. That's why we are doing like
Sir, can you
Yeah.
give an example?
because 100 square.
Sir, this is just the formula, right, sir?
Yeah, this is just about the formula. You have to use the formula pressure equals to force over area. To find out the gravitational force, you need to use this one. And if you are given this centimeter square, you need to convert it to meter square, right?
Sir, can you give an example?
Yes, sir.
Yeah, sure, sure. I'm giving you 2 questions. Try to do these 2 questions. So here, a man weighs 60 kilograms, stands on his 2 feet, stands. If the area of his 1 feet, if the area of his 1 feet is
On his 2 feet. If
50 centimeters square,
area, if the area of
find the pressure
is 1 feet is
exerted by his feet.
is 50 square centimeters. If I define the pressure, the pressure EX
Okay, Amatar.
exerted.
Yeah, Amatar, I got your message. Thanks for informing.
Sir, sir, in which unit can we measure pressure?
Pressure is measured in the units Pascal.
So should we send the answer in the chat box?
Yeah, just send a direct message in the chat box.
Yes, sir.
Okay. So, first of all, tell me, what is the amount of force that is acted?
60 kgs.
Sir, 60 kgs in 100 centimeters cube, sir.
See, the mass is given as 60 kilogram
Yes, sir.
and the force will be given by, since his body is attracted towards the gravity, he is having the gravitational force. So the gravitational force is given by mass multiplied 10. So the force would be equal to 600 Newton. Okay. Then now we need to find out the area.
The
So it,
first, I'm sorry to disturb you, sir. First, we are making this into the gravitational formula, right, sir?
yeah, actually the force that is being acted over here is the gravitational force only. Okay, it's
And
just the
also
gravitation.
the area also, right, sir? The area formula. Two times we are doing here.
Yeah, he since the area of 1 feet is given as 50 and he's standing on 2 feet. So area of 2 feet should be taken as 2 multiply 50. That is 100 centimeter square.
Sir, and sir, I sent my answer, sir.
Okay. Nayanika sent the answer and
Sir, is my answer correct, sir, or wrong? I think it's wrong, sir.
okay, if you think it's wrong, do it again.
Yes, sir.
Okay. Gautam, you also try it again. See the
Okay, sir.
conversion. See the area is 100 centimeter square and before using this, we need to convert this centimeter square into meter square.
Meter square.
Okay, sir.
Okay, so convert it.
Answer correct, sir. I have sent it.
Okay, Pranava's answer is correct.
Sir, is my answer correct, sir? I fixed it.
Charan Tej, no. Just
Sir,
see.
mine, sir? Nanika, sir.
Nyanika, Gagana, I received the answer. Gagana's answer is incorrect. Just let me check out. Just give me 1 minute.
Yes.
Okay, Nyanika's answer is correct.
Yeah, sir, I fixed it.
So mine?
Yes. Whose answer?
So Gagana.
Gagana. Yeah, it's incorrect, Gagana. Just check it once more. See here. So you have 1 centimeter square will be converted to meter square. We know 1 centimeter square is equal to 1 over 10,000 meter square. So the same we have to convert here. We have to convert 100 centimeter square. So 100 centimeter square would be equal to 100 divided by 10,000. And 100 divided by 10,000, it is now meters. So you can clearly cancel the 2 zeros. And now you have 0.01 meter square. Did you get your area as 0.01 meter square and force as 600 Newton? Varshit, Varshit,
But in 10,000, actually, I didn't cut the other zeros, and that's why I got 0.00.
okay. So Varshit, Gagana, and Pranava, your cameras again went off. I don't know why.
Sir,
So your force,
power cut, sir.
okay. So your force, yeah, Varshit, did you get the answer?
Sir, like I was having power cut, I joined my own.
Okay, so try it somehow. Okay. So we have got these values. Now we just need to put these values over here. We need to put these values in the formula of pressure, which is given as force over area. So force age we have calculated as 600 Newton. So we put here 600.
I sent my answer. Can you just check if it's correct? Sir,
Okay,
I
now
changed
it's,
my answer again.
yeah, Sreshta, your answer is correct. Gagana's answer is also correct. So 600 divided by area, which is 0.01. Just take care of the units and conversions. Your answer will be correct. Got it?
So
So
may you say after when we got 100 centimeters square, I didn't understand, sir.
say you have 100 centimeter square and we converted this 100 centimeter square to meter square. So 100 divided by 10,000, you get it as meter square. So you have 0.01 meter square.
Okay, sir. I got it.
So now you divide this by 0.01, you get 60,000. You have
Sir,
two
is
zeros
any
and
answer,
Uh,
put two more zeros, that's 60,000 Pascal.
Now is it
sir, is
correct?
any answer, sir? Is it correct?
Sir, is
Yeah,
my
now Charantej's answer is correct.
Sir, is my answer correct?
Uh,
the 600 how it came, sir?
six, earlier you had 600, the force was 600, and you divide that force of 600 by 0.01. So if you know how to divide it, see, after the decimal, you have two digits. Okay. So since after the decimal, you have two digits, so you can remove this decimal and in the numerator, put two more zeros. After decimal, you have two zeros, so you can put here two zeros. So that makes it 60,000. And 60,000 divided by 1 is 60,000. So you get 60,000 Pascal. Okay, another question of different type, a little bit different.
yes, sir.
An iron nail is hit by a hammer of the nail has an area of 2 square centimeter. Find the pressure exerted on nail if the hammer hits it with a speed of,
Sir, how speed, sir? You have to find newtons, right? With the force.
yeah, with a force of 45 Newton. Okay, so try doing this question. Just conversion of units should be proper.
So can you check if my answer is correct?
Okay, I'm giving you one more. Just do this one also, and then I'm using.
Okay, sir.
Okay, so this is another question. You can try both the questions.
Sir, I sent you the oh, okay, never mind. Yeah, I sent you the answer. Can you just check if it's oh
Yeah.
Sir, I send you the answer. Can you check?
Sir, sir, this answer everyone can see, sir.
Yeah.
Sir, Chanakya said the answer everyone can see it, sir.
Okay, everyone can see the chat. Okay, so that's why I'll be checking it after a few minutes. Just do it. So for the first one, you will be getting your answer as for this one, you should be getting your answer as 45 divided by 0.0002. So that has to be 4,50,000 divided by 2. See your answer. So you have 225,000 Pascal.
Sir, I got the same answer, sir.
Yes.
Sir, I
And
also.
okay. So for the second one, you'll be getting your answer as pressure should be equal to 50 divided by 0.01. So
Yes, sir.
that's
5,000, sir.
50,000. Yeah, it's 5,000 Pascal.
Yes, sir.
5,000 Pascal of force acting on the cylinders. So who had a doubt initially?
I got both correct, sir.
Okay, so I think everyone's doubt is clear from this chapter of pressure. Yes, everyone's doubt is clear.
Yes.
So, okay, so as promised, I'll be starting with a fresh one. That's just give me 1 minute to open up your book for Pearson. Okay, so we can continue now. Okay, your first topic being measurements. So just have a look. This topic will be helpful everywhere with the measurements. How do we make the measurements? See, as we know that all the measurements which are made. So from here, I'm taking the help. Now, the measurements which are made, we need certain units for their measurements. So first of all, can we measure everything in this world? Is everything measurable?
Yes, sir.
Yes, sir.
Yes, sir.
Even including the water, we can measure everything.
So you say everything is measurable. Can you measure how much your parents love you?
Yes, sir.
Can you measure it?
No, sir.
You could, sir.
How?
It's like an impossible value, but yeah, it's a possible thing.
It's not a possible thing to measure. There are different quantities which cannot be measured. Like how much your parents love you, it's unmeasurable. It's not measurable. It's not just a quantity which can be infinite. It is something which cannot be measured. Okay. There are different other things that cannot be measured. For example, suppose
Whole numbers.
the quality, no, the food that you eat, the taste of the food, it's not measurable.
Any emotion we can't measure it.
Yeah.
We can't measure any emotion, sir.
Yeah, we can't
Yeah.
measure any emotions, feelings, they are unmeasurable. Okay. Now, only those things which are measurable, they are called physical quantities. Okay. The things which can be measured, they are the physical quantities. So we call physical quantities as quantities that can be measured. So in everyday class, I'll be taking few minutes over here, some extra, okay, and something from the syllabus also. So physical quantities, the quantities that can be measured, they are called as physical quantities. And out of them, there are certain quantities which are fundamental, which are independent. The quantities which are independent are called fundamental quantities. They are not dependent on any other factors. So what quantities will be called as fundamental?
Which do not depend on anything.
Sir, something like all the SI quantities, SI units that are having quantities.
Yeah, the fundamental quantities, not only the SI, the quantities are like length, mass, time,
Sir,
temperature.
sir, those are all the
Okay.
things that are in fundament, I mean SI units, right, sir? Like the time
Okay.
is seconds, length is meters.
Okay. Okay. But isn't the Pascal in an SI unit?
Sir, Pascal is pressure, sir.
So
And it's an
isn't
S.
it an SI unit?
No, sir, but it's
The
not.
particle is PA. That's the SI unit.
Yeah, Pascal is the SI unit of pressure. Newton is the SI unit of force.
Force.
Sir, atom.
So they are also the SI units, but they are not fundamental. They
Sir,
are
I
derived.
have a small doubt, sir. Like I want to ask, like, from this textbook, we have anything related to force and pressure and combustion and flame. Important questions, anything.
Uh, okay, I'll look for it. I'll look for it and see.
Okay,
Okay.
sir.
So these are some of them which I have listed. There are 7 fundamental quantities. Okay. So you have current, amount of substance.
Sir, they are the amount of quantities that cannot be created with other quantities, right, sir?
Yes, they cannot be created with other quantities, and these quantities they cannot be obtained from other quantities. They are independent. They are not dependent on other quantities. Okay.
Like how pressure is derived from
Yes.
mass and mass in area or mass in length.
Yes. So see, everyone don't think that it's not a part of your syllabus. This is a little bit high level. This is your foundation. Okay, so you are creating the foundation for your exams. A foundation level course is now running. So for the fundamental quantities, we have length, mass, time, temperature. How many fundamental quantities are there? Yes, how many fundamental quantities are there?
Sir, for 8.
7, sir.
7. There are 7 fundamental quantities. And the other quantities which are there, they are derived quantities. They are not independent. They are dependent on these fundamental quantities.
Sir, is ampere a quantity?
Ampere is not a quantity, it's a unit.
Okay.
1, 2, 3, 4,
Sir,
5, 6.
but
Sir,
is it
does depth come under fundamental quantities?
Yes, what happened?
Does depth come under fundamental quantities?
Which one?
Depth, sir.
Depth is a type of length, so it is a fundamental quantity.
Sir, I have a doubt.
Yes.
Would ampere be considered at least as a SI unit, not as a quantity?
Which one?
Ampere, sir, as Sharon Tej asked.
Ampere is a unit of current.
Yes, sir. So wouldn't it be considered as a fundamental quantity?
It's not a fundamental quantity. It is a fundamental unit. There is a difference between fundamental unit and fundamental quantity.
So then
Like,
is it SI unit, sir, or no?
just wait. It's SI unit. For length, just like if you have to measure length, so we use meter. To measure mass, we need kilogram. To measure time, we measure in seconds. To measure temperature, we measure in Kelvin,
Yes,
not
sir.
in degree Celsius and not in Fahrenheit. Current is measured in ampere. Amount of substance will be measured in mole, and intensity of light will be measured in candela. So some of them you have been using, like you have been using these, a few of them.
Sir,
Yes.
sir, in joules is used for joules is used to measure what, sir?
Joules is used to measure energy.
Okay, sir.
Okay, so bye all of you. We'll meet again tomorrow. Meet again in the next class, not tomorrow. Okay. Okay, bye all of you.
Bye, sir.
Bye, sir. Thank you.